This video is over topic 42, complicating our counting process a little bit with not or complement or combining two events with or, combining two events with and. So you need to know the notation for not E with the little apostrophe, and then as well as still the number in set notation. So the number not in E is the number in the sample space minus the number in E. There's a more generally, so the number in E plus the number not in E equals the number in the sample space, because the sample space is being just divided up into whatever's in E and then whatever's not in E. So they combine to make the whole sample space. So this could also, this gives either n of not E equals n of S minus n of E, or n of E equals n of S minus n of not E. All right, so with this frequency table with grades and number of students, and A is the event a student earns an A, the students included in A apostrophe, or not A. Well, we could simply describe it as students who did not get an A, or we could describe it by what they did get, students who got B, C, D, or F. So the number in not A, this was 17 total. It's 17 minus the 7 A's. Or you could do the 3 plus 4 plus 2 plus 1. So adding up the B, C, D, and F grades, either way, it is 10. Okay, then let A be the event of rolling a 2 on a standard 6-sided die. So S, the set S here, would be 1, 2, 3, 4, 5, 6 as the elements. N of S is 6. The set A, the event A, would just have the number 2 in it. N of A is 1. So we're interested in how many are there. N of A prime is the rest. It's 6 minus 1 is 5. You could list out A prime would be, or A apostrophe, not A, would be 1, 3, 4, 5, 6. And you could count those. But if it was rolling a 100-sided die, then A would still be, then rolling 2 would be still have that one element. It'd be a lot easier to just take 100 minus 1 than to try and list out and count all the other things other than the 2. All right, and versus or in probability. Or is going to mean addition, and is a restriction, and is, we want both true. We're looking for the overlap. So think in terms of one outcome at a time. So to have A and B means we're looking at an individual outcome for which A and B are both true, or that is in both A and B. So if we're talking about students and grades, in normal language, we might talk about, students with A's and B's, but in probability, there is no such student. The set of students with A's and B's would be empty because there is no individual student that has both an A and a B. If I want to talk about the set of students that have A's, the set that contains students with A's and contains students with B's, that would be the set of students with an A or B. So super important to learn and understand what and or mean specifically in this context. Is not the usual way that you might think of what those mean. All right, so Number 3 here, a marble is selected from a bag containing 8 marbles numbered from 1 to 8. The number of the marble selected will be recorded as the outcome. And we have event A, the marble selected has an even number. So that would be 2, 4, 6, and 8. Event B, the marble selected has a number from 4 to 6. So that would be 4, 5, 6. So we have our bag with marbles 1, 2, 3, 4, 5, 6, 7, 8 marbles with the numbers 1 through 8. Event A has these marbles, the 2 and the 8 and the 4 and the 6. And event B has the 4 and the 5 and the 6. So A or B is if we draw a circle around the whole both anything that's within A or B. So it's really hard to describe what's included in A or B without using the words like both and so on. So there's this sort of mix of how those words get used. But we're looking at, is this individual marble in A? Then it's included. Is it in B? Then it's included. Is it in both? That's fine. It's still included. It's everything in A. So we could write the 2, 4, 6, 8, and then look at B and say, well, 4 is already covered. We need 5 also. 6 is already covered. Or you could look at each individual marble. 1, not in A, not in B, not included. It's not in A or B. 2 is in A, so it's in A or B. 3 is not in A or B. 4 is in A, it's also in B. So A or B doesn't exclude A and B. It can still be in both. 5 is in B, so it's in A or B. 6 is there. 7 is not. 8 is there. For A and B, that's going to be just the overlap. So it has to be in A and it has to be in B. So that would be 4 and 6. So A and B is the overlap. So think of, you have A or B. Within that is A and B. And then within A and within B is A and B. So A or B is the biggest, and then that's divided into, you know, A and B, and then where those overlap is A and B. I don't know if that helps or not. The complement of event B would be everything that's outside of B. So that's going to be 1, 2, 3, 4 and 5 are in B, 6 in B, 7 and 8 are not in B. Okay. So with or type events, we need to think about whether the events are mutually exclusive. So if there's anything in A and B, then they are not mutually exclusive. They have an overlap. That's going to affect some of our counting processes. If there's nothing in A and B, then they're mutually exclusive. They're two completely separate sets. There's no overlap. Then if we just have A and B, then the number in A and the number in B, if it's A or B, then all of this is included, all of this is included, so you just add those up. If there's overlap in A and B, then if we just take A and B and take that whole number and that whole number, Well, then they've both included the overlap. So that got counted twice. We don't want to have that happen. So then we have to subtract the overlap, which is A and B. Not because it's not included at all, but because we don't want to include it twice. So for those marbles with those events A and B, with A being the even number 2, 4, 6, 8, B was the 4, 5, 6, A or B was 2, 4, 5, 6, 8. A and B was 2, sorry, 4 and 6. Then we get this relationship number A or B. There was 5 in there. Number in A was 4. Number in B, 3. Number A and B, 2. 4 plus 3 minus 2. 7 minus 2 is 5. Those are, in fact, equal. So we didn't use that equation to find the number in A or B, but we can confirm that relationship. Okay, Venn diagrams. We're going to make a Venn diagram for these marbles. I've already done a very rough one with those shapes in the bag, but let's make a nicer looking one. So we have the whole sample, the bag of marbles. And we're just going to make a nice circle here for A and another circle for B, and they overlap. So marble number 1 is not an even number. It's not a number from 4 to 6. It's hanging out here outside of both of those sets. Number 2, it's not from 4 to 6, but it's an even number, so it's going to go in the part of A outside of B. 3, not an even number, not from 4 to 6. It's hanging out outside. 4 is a number from 4 to 6, and it's even. So here in the overlap, 5 is from 4 to 6, but not even. 6 is from 4 to 6 and even. 7, not from 4 to 6, not even. It's hanging out outside. And 8 is even, but not from 4 to 6. So we get these 4 sort of possible locations of not in A and not in B, or in A but not B, in B but not A, or in both. So A itself here, do a little thicker blue there. That's A. B is everything within here. A and B is where they overlap. And then A or B is just including the whole area there. We could also represent this type of data with a two-way frequency table. So we have rows and columns. So we could do something like basically we have A versus not A, dividing the whole sample space. And we can also divide the whole sample space by B or not B. So then we have A and B here, being the 4 and the 6. B but not A would be the 5. A but not B would be the 2 and the 8. And not A, not B would be the 1, 3, 7. So just having those same groupings, but in a table form. Usually in a table, we don't list the elements. We just say how many there are in each group. So number 6, we have a class with 15 freshmen and 10 sophomores. 6 of the freshmen are education majors. 4 of the sophomores are education majors. So we have, and which is the row and which is the column doesn't really matter. I'll do freshmen here, sophomores here. And then we're going to have education major and not education major. And then we're going to have a total for each. All right, so we are told there are 15 freshmen. That's the freshman total. So that goes here. And then 10 sophomores, that's the sophomore total, that goes here. And then 6 of the freshmen are education majors. So within the freshman row, education majors means they go here. So that's 6. Now, there's 15 freshmen altogether. 6 are education. That means 15 minus 6, or 9. The other 9 freshmen are not education majors. And then similarly with the sophomores, 4 are education majors. So of the sophomores, so that would be here, 4 sophomores, education majors. And the rest of the 10 sophomores, 10 minus 6 is, sorry, 10 minus 4 is 6 to get the rest. So when we have a table like this with the totals, the total, like these, if we have these different numbers here, the total is those things added together. If there's a total here, it's those things added together. So hopefully you understand that about tables, but that's an essential thing that is going to be how we fill out tables, by knowing that. So using the totals. So how many students in the class are sophomores or education majors? So sophomores or education majors, the sophomores are included, education majors are included. So it's these 6 freshman education majors, the 4 sophomore education majors, the 4 sophomore not education majors. So you could calculate this as 6 plus 4 plus 6, or you could do the 10 total education majors plus the other 6 sophomores, or you could do the 10 sophomores plus the other 6 education majors. If you do the 10 sophomores plus the 10 education majors, each of those came from doing 6 plus 4. And the 4 that are both sophomores and education majors, those were counted twice. So the same group included twice. We don't want that to happen, so have to subtract that. So 6 plus 4 plus 6, or 10 plus 6, or 6 plus 10, or 10 plus 10 minus 4. Or we could also look at it, the only ones not included are the 9 freshmen who are not education majors. So we could do the overall total 25 minus 9. So all of those will get a result of 16. You don't obviously have to do more than one of them, but just any one of those that makes the most sense to you.